Welcome to the lecture series on Internet of Things. Today we are going to see about Raspberry Pi. So the objectives that we are going to cover in this lecture are the introduction about Raspberry Pi, the features of Raspberry Pi, different Raspberry Pi boards which are existing, comparison between Arduino Duo and Raspberry Pi, UART, the deciding factor about Arduino Duo or Raspberry Pi, and finally about few interesting cases and extension boards that fit with the Raspberry Pi community.
To begin with another prototyping platform, that is Raspberry Pi. So like Arduino was designed for physical computing, Raspberry Pi was designed for entirely a different application. Raspberry Pi was designed for educational purpose. So this was the vision of Eben Upton. This person, Eben, he is the trustee and co-founder of Raspberry Pi Foundation. He had a vision of building a computer which was very small, inexpensive, and would be such that it could be programmed and experimented, just like if you were or if he was a child, and if he would have this computer system, how would have he programmed and experimented with it? So with that vision, he built this Raspberry Pi. So he just did not think the computer system as a passive station where games will be played, computer games. He thought of building a computer system with which even a child can program and experiment. So for this, he gathered a group of teachers, programmers, and hardware experts, and they had this foundation running, Raspberry Pi Foundation. So from 2006, they had few ideas and they started to implement them because they all were part of Raspberry Pi Foundation. So when Eben was working at Broadcom, a company, a firm, so he was working with a specific chip at Broadcom. The name of the chip is BCM2835. So this chip was a SoC. Eben was working on this system on chip in Broadcom company. And he found out that this system on chip, that is BCM2835, is having exceptionally powerful GPU. GPU, that means graphics processing unit. And it is also capable of having high definition video and fast graphics rendering. Because of this, high-end graphical applications could be implemented just like your personal computer, what you actually have, like a laptop. Apart from this, the BCM2835 also featured a low power, cheap but serviceable 700 MHz ARM CPU architecture. So he has described more about this amazing chip in an interview which you can find on this website, where he is describing this BCM2835 chip as a GPU with ARM elements grafted on. So he is describing this chip with this adjective. So this Broadcom chip is very commonly seen in your Raspberry Pi. So what is this Broadcom? This Broadcom BCM2835 is a SoC. It is having multimedia capabilities and it is usually seen in mobile phones or portable devices. And if you see, the manufacturers of this chip are not releasing the schematics of this chip in open source. So they are keeping this chip as a secret. So let us start with some history. That from where this Raspberry Pi Foundation project got the inspiration. So Raspberry Pi got its inspiration from one previous attempt which was done by BBC in order to find out that what is the amount of computer literacy in UK, United Kingdom. So they had built this BBC Micro, a small computer system. It was built by Acorn in early 1980. So this computer was invented because BBC producers had to make a TV program. And that TV program was all about showing that how computer literacy is growing, degrading, whatever was the scenario in UK. And when they were about to program this particular aspect, they realized that there is not a single and a powerful computer platform which is cheap enough existing in the market. Cheap enough so that the schools in United Kingdom could afford them. So there wasn't a single computer system which was available in the market at that time so that schools could easily afford them. And then this became the sensible topic for their show. Then from then onwards, they started to come up with the BBC microchip. So this same thing gave the inspiration for Raspberry Pi also. Because Raspberry Pi is also built with the same vision that even children can program and experiment with it. So just like we have the model names of BBC Micro, so this is the BBC Micro, that is microbit. We also have the model names for Raspberry Pi. So primitive versions of Raspberry Pi had the model names like Model A, Model B. Currently we also have Model B, but there is a number also which is associated. So in the market right now, it is Raspberry Pi 4B that has come into market recently. Then many of other trustees who were belonging to Raspberry Pi Foundation, which is officially founded in 2009. So from 2006 they started actually gathering people, and in 2009 they formed this final or we can say official foundation. So these trustees, they also got some bits and pieces of practice and experience because they were also working on BBC Micro. So they were working on this BBC Micro project and then they joined the Raspberry Pi Foundation. So of course they had some experience, some practice that how this particular small, cheap, yet powerful computer chip can be built. So they use their experience for the Raspberry Pi as well. So among all these different trustees, there was one person, one trustee, David Braben. He wrote a game for Raspberry Pi. So that game is known as Elite. You can Google it. And this especially screenshot I have put from Elite Dangerous. This screenshot, it is a space exploration game. And this game is having very high-end 3D wireframe graphics. So for a small computer chip, you can't say actually computer chip, a small SoC to have such powerful graphics is a commendable job. But as I told you, Raspberry Pi is a charitable foundation actually. Even though the Broadcom is not available in fully open source, but Raspberry Pi is a charitable organization. So apart from being into the charity, this foundation is still able to supply its Raspberry Pi boards in large quantities, and it is also focusing on how to reduce the cost of component boards more and more so that more people could afford to buy this powerful system. So the final Raspberry Pi board is costing around 25 euros, and more powerful B model of Raspberry Pi, which is having the built-in Ethernet connection, comes for around 25 euros. So in the same price range, you also have the Arduino available, but of course it comes with an entire different specifications and functionalities. So you have different boards, companion boards, which we called as shields in Arduino community, but we don't have the same shields or companion boards for Raspberry Pi, because majority of the features are provided on the board itself. So it is a system on chip, as I have been telling you. Arduino isn't a system on chip fully. Raspberry Pi is. Okay, so these are few features of your Raspberry Pi B model. So we can see it is having audio video port, it is having a camera port, HDMI port for connecting the monitor, then the micro USB power, that is the same micro USB which we connect to our mobile phones for charging. Then we have a display port, some other type of display. This is a normal, our screen display can be coming up here. So what is Raspberry Pi actually? With all these features, no one can stop Raspberry Pi to become effectively a computer which can actually run a real modern operating system. With the USB, you can connect keyboard and mouse. With that RJ45 connector, you can have internet connection. With the HDMI display, you can have TV or monitor so that high-end graphics can be played. So, aren't all these features desired in an actual computer system? So, we get these features without adding any additional circuitry to the Raspberry Pi, and therefore no one can stop it to call a effective computer. Whereas if we talk about Arduino is having a power for processing. It also has memory and storage, and it can also run modern operating system. But if you see, all the features might not be available on one board of Arduino. You might need to have some attachments connected to it, that is the shields, so that it could be a complete system. So next we can talk about the Pi Model B, that is RPi Model B, and the Arduino Ethernet. So the RPi Model B is having a built-in Ethernet, but a built-in Ethernet is also available in Arduino Ethernet. But if you talk about Arduino Duo, which we had seen, it doesn't have a built-in Ethernet. So what can you do over there? You have the USB port, so you can connect Wi-Fi dongles over there. Similarly, in Raspberry Pi also, you can have the USB Wi-Fi dongles which are connected through the USB ports. So, if there is no Wi-Fi connectivity, you can have the shields in Arduino, but in Raspberry Pi, you can have the Wi-Fi dongles connected through USB. So, this is the additional feature which Raspberry Pi provides to you. There is no need of any additional shields to be connected to your Raspberry Pi. So these are different Raspberry Pi boards. Differentiate or compare between Arduino Duo and Raspberry Pi. So these are the points and these are the specifications. So very clearly we can get an idea and we can decide that which is more powerful, or we can say which is more functional. So if we talk about CPU, in Arduino Duo, there is this, we are having 84 megahertz CPU, whereas in Raspberry Pi we are having 700 megahertz ARM architecture CPU. Here we don't have a GPU, that is a graphics processing unit, in Arduino Duo, whereas in Raspberry Pi it has a built-in Broadcom media processor. Then if we talk about RAM, we had discussed earlier, Arduino Duo is having 96 KB of RAM, but Raspberry Pi has 512 MB of RAM. If you remember, few years back, 512 MB was a configuration RAM in your PCs, in your personal computer. Now, of course, they have gone to TBs and PBs also. Then we talk about the storage. So you have 512 KB storage, that is flash, and here you have SD card storage, which is, you can have 4 plus GB of SD cards inserted to have the storage. If we talk about Arduino, there isn't a built-in operating system or by default operating system which is there for Arduino, but you do have bootloader. We have studied about bootloader. Whereas in Raspberry Pi, it is coming with Linux distributions. So we are going to study about which distribution is specially officially designed for Raspberry Pi later on. Then we talk about the hardware connections. 54 GPIO pins are there in Arduino Duo, whereas in your Raspberry Pi D model, we are having 8 GPIO pins. Then we talk about the PWM. If we know, PWM is for the digital output that we get. So there are 12 output ports which give them, whereas in Raspberry Pi we have only one. Next we talk about the UARTs, that is Universal Asynchronous Receiver Transmitter. So this type of interface where you connect the devices for the communication between different devices, serial and parallel devices, you need an interface, a intermediary communication channel, because serial and peripheral device, parallel devices are talking in different languages. So there should be a middle person to translate their communication. So next we see about SPI. So we have SPI bus and I2C bus here also, and here we have the SPI bus with 2 chip selects. So when you are having the SPI communication, you have the master and the slave. So here you can identify 2 slaves with 1 chip. So you have 2 chip selects, whereas here you don't have, you have a single. Then USB and native host is there over here, and here you are having 2 USB sockets. Then it has 12 analog inputs, 2 analog outputs, and it has, Raspberry Pi is having Ethernet, HDMI output, and video and audio output also. So as I told you, I'll be sharing the concept about UART. So what is UART? UART is a digital protocol which helps to have a seamless data transfer between two devices. Now devices can be of different type, they can be parallel, they can be serial. If they are parallel, then they are sending 8 bits at a one time simultaneously. But if they are serial, they will be sending single bit one after another in a series. So what is UART stands for? UART is standing for Universal Asynchronous Receiver Transmitter. This circuitry is responsible for implementing serial communication. So if you want to have serial communication, but if your device is a parallel device, then you have to implement a UART over there. So UART circuitry will help you to achieve serial communication with a parallel device. So UART will always help us to achieve the communication because it will act like an intermediary between the parallel and the serial interfaces. And using UART, you can always adjust the data formats, that is, in which language these two devices should communicate with each other. You can always adjust that. You can adjust the data format. That data format should be recognizable, should be understandable on both these different devices, parallel as well as serial. So you can always decide that. You can also configure the transmission speed. That means the speed at which the data bits will be transmitted. You can always configure that. So all these different features are produced in UART. It was clear that how can we adjust the transmission speeds is depending on the baud rate. BAUDRATE, baud rate. So the baud rate is considered and the actual time value or the clock value is calculated, and depending on that we have the data bits coming in and we are clocking in on that time duration, and then it is decided that a particular data bit is arrived, you have to accept it. So this was all about how UART communications are done, that is how serial communications are done. So again we'll come back to Raspberry Pi. So we had discussed a whole lot of features in the comparison chart just now, and from all of that, or from all of those specifications of the Raspberry Pi, we see that they are more capable than the top range Arduino board, that is top range Arduino, which is Arduino Duo also. But just on the basis of specifications, we can't judge that which one is a better choice unless we actually see that what these devices will be used for. So Raspberry Pi is fitting into, it fits well, very well into the IoT ecosystem, and therefore we have to look that even if it is fitting into the IoT ecosystem, how well does it fit over there? So for that we have to judge the Raspberry Pi over various constraints. Like we are going to see that how we can interact with the Raspberry Pi, how we can do physical computing with Raspberry Pi. That means how we can actually build that internet connected thing using Raspberry Pi. So we are going to, in short, judge Raspberry Pi on all the considerations what we saw in Arduino platform also, like development, programming language, debugging, openness, all these things. So we are going to judge Raspberry Pi and we are going to see the efficiency of Raspberry Pi one by one. Now apart from this, there is also a whole lot of devices which are host devices, and they are also existing in this same target market where Raspberry Pi is existing. These devices are the Chumby Hacker board, the Beagle board, and all these devices can be seen in the market. But why these devices are not as popular as Raspberry Pi? It is because these devices are very expensive. And we know that the vision of Raspberry Pi is that every person should be able to own a computer with which experimenting can be done. And it should be powerful enough as a computer system. So you are getting all these features at a very less price. So therefore Raspberry Pi is popular for one of these are the reasons. Now these boards, what you can see, the Chumby Hacker board and the Beagle board, apart from being expensive, they definitely have better specifications than the Raspberry Pi because they are giving you a price difference which is greater than Raspberry Pi. Of course, they'll be giving you some more specifications. But this is a very small reason to just consider that these boards are above our Raspberry Pi. This is not the reason that just because they are having better specifications, they are above Raspberry Pi. No. It is because any project in your physical computing can be affected by the hardware, the better tool support for a specific chipset, and the ease of use. All these things, they are always affecting a project. So if we keep Raspberry Pi in these issues, we definitely see that Raspberry Pi fares well. It is providing us with a sufficient and a satisfactory amount of service because the hardware is easier to understand. We are having a Raspberry Pi Foundation, which is the community which also provides the support. Then we also have the ease of use. It's very easy to interface the components. So because of this, Raspberry Pi has become popular. Next we come to the part that what your Raspberry Pi should actually be having as a protection layer. So Raspberry Pi had a lot of excitement about its arrival in UK media. And not only in the media, it also had the excitement in the hacker and maker community. So Raspberry Pi had a focus in these areas, in media as well as in the hacker community. And because it had the focus, this Raspberry Pi ecosystem came up with various different boards, various different components which were built around these devices so that it could be used on these devices. So as we know that Raspberry Pi can become a very powerful general purpose computer or a media center PC without requiring constant prototyping with electronic components. So not every time you are going to do the prototyping. You can also use it as a PC. So the first demand that was put forward for this Raspberry Pi board was there should be a attractive or a proper or a sturdy case in which this Raspberry Pi chip board can be placed. Just imagine your CPU which you have at your home or which you have seen, which is there with a computer system. Just imagine if the manufacturers of the computer would just give you the motherboard in your hand and would tell you that connect here the mouse, connect the hard disk, connect different cables and circuitry. So how messy and how bad that configuration would actually look. So similarly, if you have this types of casings for your Raspberry Pi to hold, then it will not only provide a good look, but it will also provide the protection to your Raspberry Pi. So there were many makers and bloggers who gave up their ideas and they wrote about what they think, which type of casings should be designed for Raspberry Pi, and they contributed their designs about the cases, protective cases, into these platforms on Thingiverse and on Instructables and some more. So many bloggers contributed their work on these platforms. There also have been some commercial projects about these casings. But Raspberry Pi Foundation hasn't released any official casing as such, that this case is official case for Raspberry Pi. They haven't. It is just because they are encouraging the lively ecosystem which is developing, which is thriving around Raspberry Pi. Because if they officialize any casing, then people will not go and invent some new innovative casings. Okay, so they wanted to encourage this vibrant ecosystem. But there are some staff members who blogged about early well-designed case of Raspberry Pi. So there is one staff member, Paul Beach. He is the designer of Raspberry Pi logo. So we have seen the logo of Raspberry Pi. So he has designed that logo and he has also designed this case, this rainbow case. So if you want to research more or search more about this casing, you can find on this website. So after that Raspberry Pi casing, now we will move to the extension board. So those casings were for the aesthetic look, that means for the good look and feel and for the protection. But beyond those, we also have these type of extension boards and they are available for interfacing with Raspberry Pi. Now what these interfacing boards or these extension boards are helping us to do. So if we are dealing with some type of development or if we are actually prototyping, then these types of boards can be of great use to us. But this doesn't mean that Raspberry Pi lacks in few capabilities and therefore we are attaching this. No, this is just as a convenient part so that you can play with the GPIO pins just to check what may be the possibilities of what you can actually do the development or prototyping with. So in early days of Raspberry Pi, whenever it was existed, when it came into market, there were very few of them which were actually providing such prototyping environment. But for Arduino, this was not the condition because Arduino was already there in the market and it had a lot of a huge ecosystem of boards. But this was not the case with Raspberry Pi. But after some time, there were a few interesting applications boards which were built. One of the board which I have put for you is the JERT board. So this JERT board is specifically designed so that the users can play with the GPIO pins and they can find out different possibilities of building an application or building a connected device. So these are just extension boards. So you can have more number of GPIO pins or connections, additional connections. So these boards are placed like this on top of this Raspberry Pi. Okay, so I have put up a wiring. You can go and search more about this on this website where you can have some information about the JERT board. You see, it's a website, official website, raspberrypi.org. You can have the information about JERT board. So if we talk about Arduino community, there is almost everything existing for Arduino because the community is so huge, so wide, and therefore lot of advancement, lot of inventions have already been done in Arduino community. But in earlier days of Raspberry Pi, this was not the case. A lot of inventions had to be done, and therefore this gave a scope of encouragement to people. So they started to do some interesting things with their own Raspberry Pis. Because this platform is so much capable, its performing capabilities, its features, functionalities are all similar to a computer system. So the invention scope, it not only got limited to designing the cases, but it was spread to how the porting of operating systems can be done, how media center plugins can be implemented. So all these inventions were done for Raspberry Pi because Raspberry Pi is a platform which is having high amount of capabilities. It is much more high level. So therefore the scope of improvement or the development not only was just about physical computing, it was about these other aspects also. So like in Arduino, they were only focusing on physical computing. Therefore, all the different boards were built. Why? With the motive of having physical computing. But in Raspberry Pi, this is not the only motive. Physical computing is just one aspect. But apart from physical computing, people also came up with the solutions. How can we have operating systems ported? How can we have media center plugins that can be implemented? All these things.
Thanks for watching.